Is now starting. All attendees are in listen-only mode.
Hello and welcome to the CIECAcast. Thank you for joining us today. We have another great program. Today's presenter is Todd Hickerson of Progressive Insurance. Todd is a 20-year veteran in the software industry, has worked at a range of companies from startup firms to Fortune 500. He has architected and built end-to-end solutions in multi-factor authentication, email filtering, and government compliance. Currently, he is a data architect at Progressive Insurance, has incorporated the CIECA BMS in the data exchange format between Progressive and its physical damage software vendor. Todd has also served on the CIECA JSON working group to help define the technical direction for its JSON software schema format. Please join me in welcoming Todd Hickerson.
Good afternoon, everyone, or good morning, whatever the case may be, if for the West Coast folks. Or just wanted to point out that if you have any questions, you can type those in the chat section of the GoToMeeting, and we will cover those at the end. So feel free to do that. Please ask questions. We'd love to get some feedback on things. So feel free at any time, and then we'll capture them at the end. Next. So the first thing I want to cover is our JSON working group within CIECA. Several of us got together in Colorado, where I'm usually located, and we went through, if anyone's familiar with the XSD, the XML schema, or the BMS, we have a file called Common Global Types, and it has a couple hundred different data elements and schema types that are basically the building blocks of the rest of the message schemas. And we had already converted the simple types and some of the code lists, actually all the code lists. Some of those we did programmatically. But the common global types really took a lot of hands-on. And while we're building, taking what's in XML schema definition, XSDs, and converting it to JSON schema, we actually built tests for those on the JSON side. So probably 6 or 8 of us got together. We each took different elements and went through and converted the rest of the nearly 200 types into JSON schema so that we could start building actual messages. And we'll get to that in a second, but appointments messages is the first one we're doing. Without the common global types being complete, we couldn't really start building any message schemas in JSON because those are the building blocks needed. Along the way, we found a few things that gave us a challenge. We're going to cover those. We also found, the last bullet point here, that there were some things specified in the XML XSDs that aren't really required. For instance, the order of things, and we'll cover that in a second. So next slide. So in detail on the issues that we found, there were a few, very short list of data types that had 2 choices within one object on the XML side. Coordinates would be one of them, and there are just 2 or 3 others. In JSON schema, you can have a list of properties and then a single choice. You can't have 2 different choices, or as they're implemented in XSDs. In JSON, they're implemented as one of or any of. And so we've noted those. We're hoping that maybe JSON schema version 5 might provide us some opportunities to address that. But at the very minimum, we're at least noting that this is an area where we're unable to enforce the same parity in the schema in JSON in these few instances that we are able to do in XML. that was one thing we found. The other was really not a big deal, but it's the XML XSDs are enforcing the actual sequence or order that the elements of an object show up in. And after talking about this with team and the JSON working team and the architecture team, we really felt that there really isn't a reason for enforcing the sequence of things in either one, in XML or JSON. It's mainly, if something's required, it just needs to be there. If it's optional, then it needs to look this way and have this data type. We don't really care what order they're coming in, and we shouldn't. But there's a tag in the XSD called sequence that if we change that to all, as you can see down the last bullet, it makes the XML flexible as far as order as well. And so that's something I think they're looking at on the architecture side for a future version of the XML schema. We also found a few little gotchas here and there that I didn't put in the slides, but overall the process of going through and converting the common global types really gave us a good understanding and vetting of things on that side, and proved to be a very valuable activity, not just for the JSON, but also for the XML. Next slide. So after that working session, we've been focusing on taking those building blocks in the common global types and applying it to the very first message structure. So we've chosen appointments as the first one to tackle, and that's what we're currently going through. And we're encountering some more things which we'll discuss in a second related to how JSON works with REST and so forth. Next slide. So before we go there, wanted to just point out a few differences, just kind of as a way of background for folks that might be new to JSON or even new to XML. The two formats, as far as data files go, are very compatible with each other. When it comes to schemas and defining what data files look like, that's what a schema is, they're very different. But the data files themselves are easy to convert back and forth. One uses curly braces, JSON, and another uses angle brackets. So that's not a big deal. XML schemas, they tend to have a much more rich vocabulary of possibilities and enforcement of different options, partly because of their backgrounds. XML comes out of a background with a lot more, it was born a lot earlier. JSON was more recent to the scene, and it comes out of more flexible and simple approach on the JSON side. So you see that reflected in even its schema. But we were surprised how close, how much parity there was, even though they have different backgrounds. And then the other interesting thing, just the last bullet on the previous slide there, Fred, the data files can be machine converted back and forth because they are so similar. They have objects, they have data, key value pairs, they have nested objects, they have arrays. Those are all easily converted, and there's tools to do that. Now, don't confuse data file conversion with schema conversion, as those are entirely different. So just want to point that out. Go ahead, next slide. Now, with JSON, and I should point out what JSON stands for, JavaScript Object Notation. So it's just a way to express in JavaScript notation data objects. So it is used prolifically all over the web, and it's used in combination with what's called REST services, or representational state transfer. We're going to hit that in a little more detail in further slides. But the key concept here is whenever we're using JSON data and we're exchanging that data via web services, the predominant pattern is to utilize a style of web services that implement what's called REST. The two are really closely tied together when it comes to data and web services. It is probably the most popular way to communicate between a native app, like on your iPhone or Android or even Microsoft, and a web server. Not transmitting web pages necessarily, although you could, but to exchange data back and forth. It's typically involving JSON, and it's implemented on the server side with RESTful web services. And then we've also seen a trend that over the last several years of many JavaScript client-side frameworks. And what that means are JavaScript libraries that run in the browser, that's the client, to exchange data between the browser and the server in a way that doesn't cause the whole page to refresh. So it can silently, in the background, transmit data back and forth without the page having to repaint every time you click a button. And so that's led to a whole lot more dynamic, more useful apps that really increase the user experience, the person using the browser app. And it's become a way to build true applications in the browser that provide an unparalleled user experience. And this is part of the reason why CIECA has wanted to implement a JSON data exchange format, because of this momentum. XML just isn't used in the same ways it was before for these newer types of implementations. Next slide. So, so why marry up JSON and REST, and what does that mean for CIECA and our standard here? Well, as our working group and architecture, we've been talking about this JSON, it's versus XML definition. We really come to realize that the companies that are interested in implementing the CIECA BMS via JSON are really going to be looking for a RESTful solution and implements the REST approach, which we're going to cover in a little bit. So what are those REST services? What are their best practices? Next slide. So it comes from a dissertation written by Roy Fielding, and it stands for representational state transfer. And it's basically, from a very rudimentary approach, it's a way to expose resources or objects, instances of objects, let's say, via web standards, via HTTP. And so an object can live at a certain URL, and you can access it there, you can do things to it, you can update, you can create objects, create more of them, change them, delete them. And it has to do with using the language of the web for data. That's really one of the main things. And in using it in a consistent way that leverages the HTTP protocol, its verbs, and its status codes. It's also self-describing. And the key is it's transmitting data. Even though it's using HTTP, you're expecting a web page, but it's not a web page that we're transmitting back and forth. It's just the data in a JSON format, typically. Next slide. So what does REST look like? Well, it's got verbs, and these verbs or methods get post, put, and delete. They really translate to read, your CRUD, create, read, update, delete, just in different order. So if you're familiar with kind of database CRUD terminology, create, read, update, delete, this is very similar, but it's more than that. There are other verbs like head, option, and so forth, which we won't really get into, but there are other verbs. Now, there are limitations as far as what kind of payloads can be sent with each verb. For instance, post says create one of these things at this certain URL. Put says update this thing. You can send it a payload of a JSON object or some kind of object in that payload, and the server will be written to act on that data and do something. If you're saying get me this object at this URL or delete this object at this URL, the HTTP specification does not allow for a body to be passed, because what would you do with it? Would it get me this object at this URL and then send it a whole bunch of data below that? What would the data? It just get thrown away. So a lot of web servers throw an error when you pass a payload as part of a get or delete. So that creates a challenge for us, because a lot of the messages in CIECA are passing just gobs of data, very rich hierarchy of objects and so forth, even for an inquiry. And we'll touch on that in a little bit when we get to the appointments. The other thing is the language of REST has a URI, a Uniform Resource Identifier, or a URL, the address line in your browser. That's where objects live under REST. They have a URL, and that's their identifier, that whole string. But there's also probably some kind of a ID field exposed. That's always in the URL. If you're getting that object, or you're going to delete that object or update it, doing a put, you have to have that ID in the URL. That's kind of different than the way we've done things with the BMS XML, where we've got this very large object with IDs embedded down below, and maybe document ID or something. So we're having to kind of rethink some of the ways in applying the JSON and RESTful approach to the BMS so that it conforms with how people expect JSON and REST to work. Next slide. So here's an example to try to put some context around this. So this is just kind of a CRUD implementation, create, read, update, delete. And we've got two gets, and then the other verbs you've seen. And the first get is getting all the books. So notice there's no slash at the end to the right of books. Like if you go to the third bullet down, get books /123, that gets a single book with, say, the ID of 123. But if you leave off the 123, it gets all the books in that whole collection. And of course, these things have to be programmatically defined. There might be context of the user session that limits the scope of data returned. They might page data. There's a number of little implementation details here, but in the concept of a query returning an array or a collection, it's typically to the resource without an ID, books being the resource. Now, let's say we want to create a new book. That would be a post HTTP verb with the URL of /books. There could be some kind of HTTP : vendor whatever.com, and you know, I'm just showing a partial URL here, so you can kind of imagine what the left side would be. That could be up to the implementer as well. And then below the post, you see a JSON object in curly braces. So it's got a title. The title of the book is REST. The author is Roy Fielding. So that's an object. And so the post method on the server that's mapped to that route, /books, will take that object, put it into its database or whatever it wants to do with it, create its record, and then usually it's going to return the URI for that newly created resource, which might be books 123. Then the next bullet, get books, that's how we would retrieve that book we just created. The put, let's say we want to change the title of that book. We would do a put to the URI, books /123, so we know it's that one book, not the whole set of books that we want to update. And change the title. The author we pass, but it stays the same. and the server will do its thing, update the book title. Then let's say we're we're done with that book, and we want to delete it. So the verb would be delete, and you can see the path to the individual resource instance with the ID. So if you can imagine, with the way we've been doing XML on the BMS side, it's been passing basically an XML file. And whereas this is a little different, the actual resource changes based on the operation, and the verb of HTTP changes on what you're doing. Sometimes it's to the collection, sometimes to the collection plus a particular element, a particular instance, an ID. Next slide. Now, there are different levels of implementing REST, and I hesitate to even say that because the guy who invented it, Roy Fielding, he actually only considers level 3 as being, quote, RESTful or REST. So we're going to take a little liberty here, but we're going to, if you want to follow up and read this article by Martin Fowler, it's tremendous. It goes into a lot of detail of each different level of RESTful design, and I think you might find it useful. So we'll go ahead to the next slide. We'll go through some of the levels here. Level 0 is, if anyone's familiar with RPC, a remote procedure call, remote procedure invocation. It's just, it doesn't implement standard verbs or a standard pattern like you see with REST, where it only knows basically 4 verbs plus a couple extra. And you pretty much have to design all your resources around those 4 verbs. That's a different way of doing things than we used to years ago with, you know, object, kind of more an OO thing, where we would say, you know, if we had a animal object and we derived a subclass of dog, and then we put a verb on it called bark. You know, that's the way we used to build a lot of systems internally with OO design. You know, the verb bark might be on that particular object. Well, that's not a standard verb. That's not one of the 4 RESTful. So, but folks do that. So that's one approach. It doesn't really qualify as RESTful at all. You're not going to see this anywhere in being presented as being RESTful, but it is one of the states of maturity along Richardson's model. So next slide, level 1. So this level implements the resource. So our /books, and it would basically send everything to a post. This is what's commonly done. The only HTTP verb used would be a post. We do /books, and then somewhere in that content of that payload, we would tell it what we were really wanting to do, like create a book or get the books. Well, and I actually probably should say that's probably more like what we do today with the BMS is inside certain objects, we tell it what we want to do. And that's okay, and that's certainly one approach. If we're trying to get greater adoption of this JSON schema utilization within the BMS, we really need to go a step higher, and that's on the next slide. This is what folks are going to expect. They're going to expect the standard 4 verbs. They're going to expect standard HTTP status codes to be passed back from the server saying, you know, a 200, I succeeded, or okay. 201, I just created this. 203, like for an update or a delete. There was no content returned, but it was successful. A 400 series status means something got sent to the server that didn't validate, or you didn't send the right kind of thing, right kind of object, missing required fields. And so then there could also be a payload along with that response that would say you missed these required fields, or this date wasn't formatted correctly. So that's the language of the typical RESTful interface, is using the standard verbs and utilizing and leveraging those built-in HTTP status codes that are already part of the HTTP protocol. Today in CIECA, in the BMS, we utilize a standard response message, which is great. We can still use that as a payload, but layering these HTTP status codes on there as well would be very useful to specify. Next slide. Now we get into certain things that we've also seen some divergence between how we want to do JSON and what we're currently doing with XML. So, but I need to lay some groundwork. We have one thing known as safe versus unsafe, and idempotent versus non-idempotent. So safe calls, and level 2 expects this as well. So if we're going to implement level 2, we have to abide by this. We can't, on a get method, go change the name of the book, for instance. We can't change the data. It does not modify the representation of that resource. Idempotent means, can I call this over and over and get the same result? For instance, if I do a post over and over and over, it should throw an error the second time I throw it because I've already created that book. So now we're going to go through each of the verbs on the next slide. Go ahead. And we're going to classify them. The next slide, Fred. Oh, not the next one. Okay, we will in a second. Level 3 implements a whole nother level of, it takes level 2, and instead of the caller having to know what all the operations are and the URLs of everything ahead of time, it can call the book's URL and get back all the books, and then as part of that return data, it can embed links to fetch a book, create a book, delete a book, and so forth, right in its result set. And so it's kind of for more of a dynamic approach. It's really cool. It's definitely where things are headed. And it's really something that we need to get to level 2 and then see what operations we want to expose on the collection as far as embedded links. So it's probably not our immediate target. It's something to keep in mind. It might be the direction we end up going, but we really need to get level 2 worked on first and then see what we've got and see what kind of support there is for this. Are folks interested in level 3? So that's something we're exploring, but we're not biting into wholesale right now because we're really trying to get to level 2. Next slide. Okay, so yeah, it kind of recaps what I just said. So level 2 for sure. Level 3 we'll consider, and based on response and need and where it's at. Next slide. Okay, so now back to, so we need to kind of lay some more groundwork on these. We covered these 2 concepts already, so next slide. Okay, so here's where when we're implementing level 2, we have to follow this grid. When we're implementing a get, we can't go change data. That means it's safe. We can't, when we implement a get, we need to be able to call that same get over and over and over and get the same result. When we implement head, which I'll skip that one. Options and head we'll skip. Patch we'll skip. Put. When we implement a put, can we send the same update over and over? Yep. Does it modify data? Yes, it does. So that means it's unsafe. It means no unsafe. And that's okay. That's the way that method's designed. It modifies stuff. But it can be called over and over and get the same result. A post, to create something, when you call it the first time, it creates it. If you call it the second time, it's not happy. And yes, it modifies, so it's not safe. A delete, you can call over and over and without throwing an error. And it does modify, so it's not safe. So this gives us a framework as we're developing and mapping the XML methods to JSON in a RESTful way. We constantly have to refer back to this and make sure when we're implementing a GET, it satisfies those requirements and the delete. And all four of these main ones, we need to make sure we're following this grid. Next slide. A little bit more about resources. You saw the example where books was a resource. That's the Uniform Resource Identifier or Uniform Resource Locator URL. That's key in RESTful. That is the location. Its ID, it doesn't change. It's always the same. And that's crucial as well. If it's the same resource, then it should have the same URI. If it's a different resource, it should have a different URI. I know this kind of seems obvious, but sometimes when we're designing things like this, those key concepts are really crucial. The ID is in the path, it identifies it, and for searching and querying, we typically omit the ID, or we pass other things like search criteria in the query string. Next slide. All right, so now on to applying what we've learned here to the Appointments API. And a few differences first. So there's a resource, we'll call it, called Appointment Confirmation, that it's on the XML side. Because with JSON, we're immediately creating or not creating the appointment, we have a little different workflow, and I'll show you a picture of that in a bit. We saw no need to implement the appointment confirmation object and those calls, that message. So we're just going to omit it from the JSON. There's an alternate flow when creating or when getting an appointments list that if your requested appointment time is available, go ahead and create it. We're not going to implement that because that violates the safety of the GET method. So creating an appointment while trying to get the appointments list violates that RESTful safety. Next slide. And the idempotency, both of them. So it's not the greatest picture, but over on the right side, you can see the alternate flow. That along the top is the get appointments, get available appointments, if you will. And if your requested time's available, then it jumps down and goes to the bottom and sends back, yep, I got you scheduled. So in JSON, we're going to implement that with two separate flows. One, get the list of open appointments. It would be the third on the left, third down from the top, would be to do a post to appointment, or it should be appointments. So we'll do a get appointments with a query string at the top, and then the user picks the appointment time they want, and then send back the post. This is how people implementing a JSON-based RESTful approach are going to expect things to operate. So we're changing things a little bit for that. It's still the same content, the same objects for the most part, but we're implementing this in a way that makes sense for JSON and RESTful. Next slide. Okay, so the appointment inquiry, so the get to the /appointments has all of this stuff. So each of these bullets is a very deep object with lots and lots of elements. Some required, some not, but it's utilized to do the search to get the available appointment times. So for now, we think we can fit enough elements. Go ahead to the next slide, Fred. We think we can fit enough of these in the query string line past on the right side of the question mark, and you just populate the things you want to ask, the things you want it to filter on, the information needed, not trying to fill in the world on each of these objects. And most of that's in the event info, so just populating a few fields there will be sufficient, and maybe a few other objects for context to pull back appointment times. There's just a lot of empty things that are in those objects, but we have a 2,000 character limit on the query string. So, but we can't pass a payload on a get. So that's kind of our dilemma. A payload being those deep nested objects. Only a post or a put can have those. So we're trying to fit to the RESTful conventions, but also trying to utilize the objects and conventions in the VMS. So hopefully we're striking a good balance here, and we'll see how this plays out. Next slide. Okay, so you can see a little bit more. We've got get / appointments, question mark, and what's in between those carets will be whatever the field value pairs or the objects that get filled in, the requested time, the claim, the whatever else is filled in those fields. That would all be on that line. And what gets returned is just like it does in the XML world. It's an appointment inquiry response, the RS. And so you can see we've got the same objects, but utilized in a little different way. What's also returned is, on the JSON side, the RESTful side would be an HTTP status code. And that's in the header of the response. So you see some of our challenges here. We can't send a payload on the get. We'll serialize the JSON. There are frameworks to do this, and the limit of the 2,000 characters. So next slide. Now jumping, let's say you've got the list of available appointment times, and now you've selected one, and you want to go ahead and schedule it. So the format for that, the payload is a selected appointment add request. That's the object in the VMS that defines what that payload looks like. And the response is a selected appointment add response, just like in XML. And of course, we'll get the HTTP status code as well. So yeah, that's that one's really straightforward. Very similar to what we expect in the XML side. Next. Cancel is really a delete. As far as we're going to map that to the RESTful, the HTTP verbs, that would be, hey, I have this appointment, I want to cancel it. You're really asking to delete it. So there's the three objects inside in the appointment cancel request. It looks like that. Service provider name, document info, and event ID. Now, and it defines the return as well as a response. Next slide. Now, what this looks like in RESTful JSON world is a delete HTTP verb to the URL of appointments / and then the ID of that appointment. The ID you got when you created the appointment. And so that's in the path, the URL. So we can't just send, like we did on the post, a big old payload that somewhere in that payload has that ID. We have to specify it in the URL. That's a big difference. So in the way JSON services are expected to operate, we have to have that ID. And we're going to see the same on the put. So next slide. So that, just in summary of what we kind of covered. So it's more than just a data format conversion, more than just XML to JSON. We can convert files back and forth on that all day long, but it's really more of a convention of how you interact with web services that JSON has brought into the picture. Has specific verbs. You're limited to the language of HTTP. This is where everyone is going, or has gone. So this is right in line with industry and technology trends and direction. It's been out there quite a while. I'd say one of the frameworks I've utilized, web frameworks, utilized this RESTful pattern 9-10 years ago. So the Ruby on Rails framework has implemented this. The URIs are what it prescribes for the resources, and just our differences in basically gets and deletes for the most part, and puts. Next. All right. We're at questions. I hope there are some.
Yeah. Yes, I've got one here. Are there any production quality JSON validation tools available?
Yes. So we've been using, there's a number of them. If you go to JSON, JSON-schema.org, let me just verify that's JSONschema.org. That has a list of tools, yeah. JSON-schema.org, and on the right-hand side at the top, you click on software, and one of the sections is validators, and it shows 28 different options in all kinds of different languages. For our internal testing on the schema itself, where we create a test file for each different object we're creating, and then we're using the TV4, Tiny Validator 4, and we're wrapping it, so that's in JavaScript. We're wrapping it with a grunt task that goes and runs through all of our test files and validates them against the schema. So yes, and that would be very good to do in whatever implementation you end up using.
Okay, I've got another question, and it says, how will we know at runtime what the available appointment slots are? That may be a question that relies on the appointment itself. So do you happen to know that, I know you're working with the technical side of this, Todd, but do you happen to know much more about the appointment side of this or not?
My understanding is that getting a list, if this is about getting a list of available appointment slots, that's very similar to what we're doing today on XML. The only difference is we're not going to auto-schedule one with that call on the JSON side.
Okay, I get it. Yeah. So that
Okay.
it'll be the same as today.
Yeah.
Yep. Yeah. Okay. Good.
If that didn't answer your question, please ask for clarification. I'll try again.
Okay. Another question is: are you implementing authentication and authorization?
We have not specified that. We think that's something that's more up to the implementers of the services and between service provider and the client. But if that's something that there is interest in coming up with some standards around for the CIECA implementation, I mean, there are a number of ways from, there's just, you get into so many different technology and stack implementation issues there. There's, JavaScript web tokens, JWT seem to be one of the predominant ways, but no, we have not, but if that's something you want, then maybe bring it up to architecture and the JSON working groups.
Okay, and we have one more. Well, I think I can actually answer this one. How can I get access to this documentation? This CIECA cast is being recorded and will be on the website within the next 24 to 48 hours, as will a PDF of the slides. So that's how you can get your access on it, get your hands on the documentation. I don't see any other questions in the queue.
All right.
And so,
well, thanks everyone for, yeah.
Yeah. No, I want to thank you, Todd, for sharing your knowledge and expertise with us. We have an exciting lineup of CIECA casts this year. The remaining CIECAs include 2015 R1 BMS release package, What's New by Dan Webster. In July 21st, we will have the value of reusable code. On August 18th, we will have a presentation on a new first notice of loss technology. In September, we take a break because we have the symposium. Back in October, we'll talk about what's going on within each of the CIECA committees. And we round off the year in November with the 2015 R2 release package, What's New. I hope you attend and find all of these informative. We would like to invite you to our 7th annual symposium in Tampa on September 14th through the 16th. There will be excellent networking opportunities for everyone. There'll be 2 tracks of sessions, business and technical, something for everyone. Within the technical side, we've got a business view of data security, latest trends in automotive recycling. We've got future trends by the Microsoft evangelist. We will have MSO's view of the CIECA standards, something for repairers. We'll continue on in our series of technology trends in JSON, and kind of round off with some schema guidelines. The complete conference program will be available when registration opens on May 26th. We have a great lineup of speakers and topics with a great location, Tampa. Networking opportunities at the conference are excellent. We hope you'll attend. That concludes today's CIECAcast. Thank you for joining us, and have a great day.